Hello everyone. This is my presentation of the article presented at the Brazilian Conference on Composite Materials. My name is Paulo Machello from the Universidade Center Senai Cimatec. The other authors are Moisés Ferreira, Luara Batalha, Gleice Maria, and Cristina Perez. The title of my article is The Systematic Review of Glass Microspheres HGM as Reinforcement in the Cementitious Matrix. I would like to thank BCCM5 for accepting my work at this important conference. Here you can see the presentation content composed by introduction, main objectives, materials and methods, results and discussion, and finally the conclusion. As we know, the cement matrix is the most used material in the construction industry. The Federação Ibero-Americana de Hormigão Pré-Mesclado showed that cement consumption is estimated at 1.9 tons per person per year. Over the past few decades, the scientific community has directed efforts to develop lightweight materials and engineer solutions. Two big reasons are more cheaper to produce and transport, and the flexibility design are increased. Another important challenge is to have a balance of resistance and weight. Therefore, a range of new technologies has become more important, especially advanced materials and additives, including a new material denominated hollow glass microspheres or HGM. So now you can see the application and benefits of HGM. The two general applications are filling material, reducing weight and costs, and reflective effect of the lights emitted by vehicles on roads and highways. Going deeper into the use of microspheres in concrete and mortars, we can find multiple benefits and suggestions. These benefits are workability, floatability, mechanical properties, rheological parameters, thermal resistance, and reduce the weight of in the hardened state. The review aims to investigate in the literature an optimal percentage of AGMs that have allowed the development of high-performance mortar and concrete, highlighting the best relation of physical and mechanical properties. The material and method of this work has focused on selecting the relevant base data in Scopus, Science Direct, and Brazil and Portugal repositories about use of AGMs in work and research with help of the specific keywords to find this work related at that theme. The keywords are AGM, mortar, concrete, and cementitious matrix. A total of 9 relevant articles are selected and 4 dissertations. Here you can see the two graphics. The first graphic on the left shows the numbers of publications in the last decade. We can see clearly the number of publications has increased of the 3 last years. The graphic of the right shows the P chart. We can see that Brazil has the highest percentage of number publication about the team. In this part, we can show these results of about my work. We can see here a table about the results of others to use AGM in concrete. Three important things you can see here are the range of percentage of AGM used in additive of 0.4% to 50%. A variability diameter of HGM in these researches and the impact of mechanical physical performance in concrete. For example, the author three are found as increased by 30% of compressive strength, and the other authors also find increased at 10 to 15% with the optimal workability result. Another important thing is that the incorporation of AGM in concrete, according to the literature, have also shown an increase in the workability and flowability in fresh state properties. In the silver dissertation, again of 100% consistency as obtained with the addition of 1% AGM. However, the resistance is reduced by 5%. The standard deviation is higher, which can be not assumed statistically significant for the reduction in the compressive strength. Another work conducted by Korolev and Inosov has studied interface zone with the cement and the constituent minerals. The author obtained the following results: high specific strength at 24 hours of molding, due to capacity of cement and mineral constituents coats the aggregate particles and provide a uniform contact area, and improved the adhesion between the surface of the microsphere with the cement matrix, especially using nanoscale surface modifiers based on iron hydroxide and silica. Now, show the review about mortar, we can see that the range of percentage additives in mortar also the variability of density as obtained and a variable comportment of mechanical strength. For mortar case research, this found in application of mortar are fillings, oils, wells, and foaming growths. It is important to highlight the interaction of the amount of HGM incorporated with the reduction of mortar density. Shahidan et al. Obtained a reduction of up to 20% of the density and gain of thermal resistance and increase of compressive strength with 3% of HGM incorporation. The optimal percentage to gain a lower density is 9% of HGM in this result. Perfilov has studied the incorporation of 10, 30, and 50% of hollow glass microsphere for mortars. They have noted that flexural and compressive strength are higher at high temperatures and low density and good thermal conductivity. The use of AGM in mortars provided good results in the acoustic resistance of the composites. This effect is due to the presence of the empty interstitial promoted by the microsphere between the minerals in the hardened state. On the other hand, these voids influenced the water absorption of the mortar. Now, after our results be shown, can be concluded an optimal percentage of HGM in concrete and mortar is essential to obtain a better strength-to-height relation. Due to spherical geometry, the surface area of HGM is shown to be benefic on concrete and mortar's fresh state. On hardened state, HGM can improve the contact area, increasing the microstructure interfacial adhesion. HGM can be used as a filler to improve thermal and acoustic resistance. Over the last decade, there are few studies of AGM in a cement matrix, especially on the impact of the microstructure. This can be an opportunity for future research to better investigate these properties in concrete and mortars. I will end my presentation here. Thank you very much.